Uh, Sir, good evening, sir. We'll start, I think. So, good evening. Yesterday we started with that I square R loss in transmission line, and the line losses on unit generated is equal to, sorry, 1 unit replaced is equal to 2 units generated. The two concepts we discussed. So we are still in the beginning stage. We'll try to complete this chapter today. Heat rate also we discussed, I think. The voltage raised for transmission of electrical energy 11 to 33. The loss will become 1 by 3 square. That is 1/9. This one we already discussed. We need not go into this again. Sir, we'll see the general tariff structure generally discussed in a textbook of the power system. This may not be 100% applicable to our board or some other board, but our exam is conducted for the whole nation. So they'll be asking for the standard tariff structure, total available. So we'll glad to write all those things. First thing, apart from the energy we consume, pay for that energy consumed. That is, we are paying in our domestic service. Whatever energy we get, whatever energy we consume, we pay for that. It is not so simple for all the consumers, such as commercial, industry, HT supply, and many other services are there. So it is not as simple as a domestic service supply. Importantly, the maximum demand charges. The maximum demand charges is the maximum demand registered during the billing period. Billing period means maybe 1 month or 2 months according to that particular discount. Why this maximum demand charges is so important? Because as we know, we discussed already, the maximum demand is the culprit which raises the peak demand. If we diversify our loads or equally distribute our loads, the maximum demand will come down, naturally come down. So that suppose we can, if we can reduce from 17,000 megawatt demand to 16,000, you will say, already I told you, nearly 8,000 crores of rupees. So it is a direct impact, not only the generation, it is also required for the entire network, LTHT network and transformers. That's the energy charges. It is a kilowatt hour a consumer uses during the billing period. Power factor penalty. It is also available in our discounts. It is being in the one consumer is being penalized for not maintaining the power factor. If it goes beyond the limit, the power factor penalty will come. He has to pay for the power factor, not compiling the power factor. And fuel cost adjustment. This is something new, sir. Fuel cost adjustment means generally in Western countries, maybe it may be there. I don't know exactly. Fuel cost means the power supply, that is the discom or the generating station. Whenever the fuel cost rises, they will raise the energy cost, because whatever energy we are getting is from fuel one, coal or oil, gas or anything else. Electricity duty charges. Duty charges levied with respect to units consumed. We can say it as a tax. Duty charges in proportion with the energy we consume. Meter rentals. Generally, the discount is supplying the meters, and they get a nominal charges of something 50 or rupees, 100 rupees per month as rental. Like one BSNL was charging for the phone, landline phone as rental. Previously, I don't know whether they're still utilizing that mode of payment. Time of day rates. This is for peak and non-peak. I think this has not come into effect for our Panjatco. In the advent of smart meters, this definitely is going to happen in near future, because we have surplus in daytime. So actually, our supply is surplus in daytime because of the solar power plants. In future, it will go beyond our requirement, and we will be encouraged to use power supply during daytime, and we will be encouraged to use the power supply at a lower cost. This will happen definitely in daytime. Penalty for exceeding contract demand. Supposing if a service is available for 100 kVA, whenever they go beyond 110 kVA or something, they will have to pay for the extra 10 for up to 100 kVA. They will be paying for some rupees per kVA as standard charges per month. If they go beyond 100, say they go beyond 110, they will be penalized for that 10 kVA. Penalty means it will be in the order of double the amount of regular charges. Suppose why they are penalizing? Otherwise, they will not pay for the regularly. They will not pay for the amount. They will get the demand for contract demand for 50 kVA, and whenever it exceeds, they will pay the same amount. So it is a loss to the discount, and that's why they are penalizing the consumer for exceeding contract demand. Existing. So, denote the terminology discom. Discom is nothing but distribution company. Sir. We have got only one company in Tamil Nadu. I think Andhra has got 5 or more discoms. In the old electromagnetic meter is also there is a facility is there to measure the maximum demand in a preset time. It can be set for 30 minutes or so, and this is reset at the end of every billing cycle. Active energy kilowatt hour, reactive energy kilowatt, or kVA, we usually call it as or kVA. Or kVA means kVA reactive. That is the colloquial language, or kVA. Apparent energy is kVA hour. kVAH is nothing but power without power factor. this active energy kWh and this kVh both will be same if the power factor is unity. Cos phi is 1. The angle between the active and reactive power is 0 means the power factor will be 1. That is cos 0 will be 1. Then the first term and third term will be same. This is picture on a very simple example. Is using 2500 kVA for 4 minutes, 3600 kVA for 12 minutes, and so on. The numerator will be like this, and the denominator will be the total minutes. 12 plus 8, 20, 26, 30. So this is the average demand. Demand curve. See, the demand is going up and down. The area under this curve is the energy consumed. The modern meters. The modern meters are substantial memory for logging all events. Previously, the electromagnetic meters did not have such a facility, logging of events. They are all high accuracy meters because there are no moving parts. Suitable for time of day tariffs. Suppose that if the government, if the DISCOM announces just 3 rupees for power supply per unit during 10 a.m. to 3 p.m. because of the surplus solar energy. How can we measure this time of day tariff? It can be done. It can be easily implemented through smart meters. It is possible through the modern smart meters. Tamper detection. The modern meters cannot be tampered. If it is being tampered, the meter will record the tamper also. Measurement of the harmonics and total harmonic distortion. The harmonics and all that is a separate subject, sir. If time permits, we'll see to it in the end of the 10 chapters. Long service life, since there are no moving parts. While typing this, I thought of the old fans or ceiling fans. They are all moving, but still they are running smoothly for more than 50 years or so. The moving part and the non-moving parts are correct, acceptable, but at the same time, it's the quality of the product that only extends the life. If both quality moving part and non-moving part both are made with very high good quality, then we can compare. Moving part will have less life, and the meter with moving part will have less life than the meter with no moving parts. Remote data access is available. The smart meter will have a SIM card, and with the SIM card, the engineer can access the individual meter from remote, and he can also download the energy consumed and other data to his computer. It is possible in the smart meters. A typical charge. Charges of utility bills, maximum demand, building demand, total energy consumption during peak hours, MD charge, energy charge, power factor penalty, total, etc. Just have a look at it. We don't need to mug up all these things. How to encourage a consumer to use the electricity smartly. And it is the load curve shall be presented to the consumer. How can we present? Can we draw all those things in a sheet in presenting? It can be done through a smart meter. Smart meter with additional gadget connected to the smart meter will give them to the consumer a load curve so that he can diversify the loads. This information should be available to him, otherwise you will not do all those things. Rescheduling of load. What is the rescheduling of load? Rescheduling of load means normally we meet the peak demand during during morning peak and evening peak. You may ask consumer, we are asking consumer, ST consumers and all, but not the domestic consumer, to use the load, unimportant load during daytime, not during the peak hour. Storage of products. What is the storage of products? Suppose we cold storage is there. They are freezing the food products and keep it in a storage. They can do it for if they are running it for 12 hours and maintaining the temperature for the other few hours, then during the production time, the food will be processed and freezed, and that time can be during daytime to help the utility to manage the loads. Can you do it? No. We have to give some incentives. Then only you will do that. Otherwise, you will not do. It is just a point. Storage of products. Storage of products means we can use the freeze the products or food products during daytime. That is when there is surplus energy, solar energy is available, and keep it in the keep it with minimum consumption of load during night time. Rescheduling of load. What is the rescheduling of load? Suppose there is like a apartment compound gated community and all. If the pumping may be 500 HP motor may be there, and it may be running for 5 hours or 6 hours for the entire community, and we may ask them to run the motor during daytime. What is the purpose? It will run and store the water in some elevated tank or a tank. If it is run during the peak or peak demand, what will happen? Once again, we have to face that capital cost and everything due to peak of high peak demand. So it's a kind of rescheduling and storage of products. First one we saw, we have to present the consumer the load curve. Fourth one is shedding of non-essential loads. Captive generation set. Supposing a company is meeting its demands during peak hour, if it goes beyond the contract demand, and we will be asking to use their generator set or something. reactive power compensation. This is done by utilization of capacitors. This we will be seeing in the subsequent slides. This is the maximum demand controller, sir. What is that maximum demand controller? Consumer is paying this because he has to pay the penalty for not complying with the maximum demand restriction. C. Whenever the load goes beyond maximum limit, that is beyond contract limit, this automatic maximum demand controller will shut off the unimportant load. It will cut off the unimportant load. Unimportant load, who decides? The consumer has to decide and connect with the particular terminal. So as to switch it off when the maximum demand reaches the threshold limit. This is available in the market. This maximum demand controller. So this is the power factor. Horizontal line is kilowatt. And the hypotenuse is kVA. The opposite side is kVR reactive, kVA. Otherwise, kVA sin theta. This one is kVA cos theta or cos phi. Simple trigonometry, sir. See if the phi goes near 0, what will happen? This hypotenuse and this adjacent sine both will be equal. Then kVA is nothing but our kilowatt. kVA and kilowatt become same when this phi becomes 0. The reactive kVR, kVA sin phi will become 0 because sin 0 is 0. One example, sir. Chemical industry had installed 1500 kVA transformer. Initial demand of the plant was 1160 kVA with power factor 0.7. To improve the power factor and to avoid penalty, the unit had added 410 kVA in motor loading. The improved power factor is 0.89. Okay. They are given the answer itself. So an example, what is see in the first case, the kilowatt is 8 volts. In the new case also, the kilowatt will be 8 volt because it is a requirement we have. Previously, the power factor was very poor. Power factor is 4 means the angle will be large. Power factor is best means the angle will be less. That's all. For 0.7, the RKVA, the reactive kilovolt ampere was 828 and kVA was 1160. Now it has become kVA has become 913, kVA become 418. 0.7, 0.18. This is achieved by using that. What is that, sir? The unit had added about 410 kVA motor load. This is the capacitor bank they have added. What is the advantage of capacitors loading? For best performance and reduce the loss in the line, the capacitors should be connected at the load end. Okay, sir. The point we must keep in mind, they should be as close as to the load. The capacitor should be closer to the load. In keeping the capacitors close to the load end, What will happen? The I square law or loss in the line is reduced. Total drawn, current drawn from the source end is reduced. Voltage level at the load end increases. KVA loading. So all these points you must keep in mind, sir. They'll be asking for Y marks. KVA loading on the generator side, as also on the transformer and lines up to the capacitors, reduces, giving capacity relief. What is the capacity relief? You see that words are capacity relief. What is that capacity relief? The smaller betterment done in every consumer end will relieve the utility. Utility means the distribution company from having a big maximum demand, peak hour demand. This is what this word means, capacity relief. Capacity relief means not only power plant, it is also for lines and transformers, etc. Wow. What are the cost benefits of capacitors? The maximum demand charges will come down. Within the plant, yesterday we saw nearly, I think it was 10% loss. I think we saw within the power plant. Sorry, this is the factory for the distribution switch gears. Usage of capacitors will make the losses within limit. We will have better voltage at the motor terminals. Otherwise, voltage will drop. Penalty reduced. Investment on the system, such as transformers, cables, switchgears, etc. For an HT consumer also, same thing happens, will be reduced. Automatic power factor controls. What does it do, sir? You can see the capacitors connected through the switches, and then all these things are connected to the three phases or YB, and their measurement will be head on line. Whenever the power factor becomes worse, the capacitors will cut in one by one. And power factor, when the power factor gets improved, then this will capacitor will automatically cut off. A simple power factor controller monitors a displacement power factor. The controller displays the power factor on a digital display and compares the measured power factor with the desired power factor. If the power factor is less than the desired power factor, another bank of capacitors is switched on via a relay output on the controller. If the power factor is leading or is above a threshold point, the capacitor will be switched off automatically. KVA or rating. Sir, please keep this in mind. KVR means it is a capacitor KVR requirement, which is equal to the kilowatt 5.1 original tan 5.1 minus new tan 5.2. These are all modified formulas, or what we have read in what we have studied in the degree course. We are not aware of the all these things. These are all modified to suit directly place the formula to find the required data, required rating and all. Example, the utility bill shows average power factor of 0.72 with an average kilowatt of 6.7. We have to take this as base. How much KVR is required to improve the power factor to 0.90? This is also simple. The new power factor, required power factor is given, existing power factor is given, the kilowatt is given. You have to find the capacity of the capacitor. It will be the direct question an energy manager has to answer. You can use cos phi 1 0.72. So do you want me to solve this powers? Can you solve this with your calculator? I think you can do it. Just find the from 0.72, you can find phi 1, sir. How can you find phi 1? 0.72 inverse cos. We'll get the value of phi 1. From that, we can find tan phi 1. Tan phi 1 is 0.963. This can be done in a calculator. Phi 2 also we can find 0.963 minus 0.329. The kVA required is equal to 398 kVA, or the nearest will be 400. So we can order capacitor for 400 kV per kVA. Location of the capacitors. See, the capacitors are fixed at the, this is motor, sir. Motor and the capacitors are near the motor end. What is the advantage of fixing capacitors at the load end instead of fixing the capacitor, total big capacitor at the mains end? What are the advantages? Advantages are the load capabilities of
அமைதி அமைதி நீ கத்துறது அப்படி கேக்குது சரியா? மன உளைச்சல் இப்பெல்லாம் சத்தமா பேசக்கூடாது, பொறுமையா பேசணும். காதுல போறது கொஞ்சம் சின்னதா போட்டீங்கன்னா சவுண்ட் கம்மியா கேட்கும், அவ்வளவு பெருசு போட்டா காது அதிகமா தான் கேட்கும். உன்னை போய் காதை போய் செக் பண்ணு, காது கேக்குதான்னு தெரியல உனக்கு.
கொஞ்சம் பண்ணலாங்க. For example, we may be having several motors in the factory, and each motor is added with one small capacitor, sir, instead of having a one big capacitor at the mains end. This will make the what are the advantages, sir? Because it will improve the system capability of the system. It is an obvious result. But see, the capacitor is connected with the motor, and only when we switch on the motor, the capacitor will come into the line. Otherwise, capacitor will be out of service, not in service. So whenever we require, we can use the capacitor. This is the greatest advantage with this. Better voltage regulation, because capacitor use follows load. We need not calculate the load and cut in the capacitors according to the load. This is simple. No automatic system is required. We can use the capacitors whenever we switch on the motor. The capacitor will automatically cut into service. Capacitor size is also simplified. Yes, capacitor coupled with equipment, and move the equipment if rearrangements are. Supposing if you are removing the motor to somewhere else, the capacitor will go along with the motor to the new location. Disadvantage: small capacitors instead of a big capacitor will cost definitely more. Certain points we need to consider, sir. Should be noted that capacitor should not be greater than the no load magnetizing kVr. The capacitor should be less than the no load magnetizing kVr. We get that point, sir. The magnetizing current will be inductive load, and capacitor will be capacitive load. This this capacitor should not capacity current should not be more than the magnetizing kVr. It should be equal. If this condition exists, damaging over voltage or transient torque can occur. Excess of capacitor is also harmful to the system. That's what they are telling. This is why most motor manufacturers specify maximum capacitor ratings to be applied to a specific motors. Yes, sir. This point we have to keep in mind, sir. We should use the optimum size of capacitor. You should not exceed the limit. Other consideration. And the loads contributing to power factor are relatively constant. The system load capabilities are not affected. Correcting at the main service could provide a cost advantage. What they are saying is, if the load is not varying, means motor and all will consume constant voltage, constant current, and it will not vary with the like other loads that we will see. Furnace and all will be much varying. Steel industry and all, the load will be varying drastically. In that case, we need not put the capacitor at the load end. We can put it in the group wise. We can put it so that we can save cost for installing the capacitors. That's what this particular paragraph means. Where the loads contributing to power factor are relatively constant, the system load capabilities are not factor. Correcting at main service could provide a cost advantage. When the low power factor is derived from a few selected pieces of equipment. If some few equipments are poor and capacitor, we can connect the capacitor particularly in that equipment. Adjustable speed drives has increased the complexity of the system of power factor for its corrections. This are all this will be generating waveforms, and this speed drives, variable speed drives and all will be affecting the system. The harmonics and all will be coming into picture. So this all will make the system much more complicated. Just an information, that's it. Capacitor for other load. Yes. This induction furnaces, induction heaters, arc welding transformers. All these are having much variation in the load. What is the terms of 1020? The power factor of arc experiences by wide variation from 0.7, 0.9. Power factor for welding transformer is corrected. A normal PF would be in the range of 0.3. 0.35 is very, very poor, sir. See, wherever you see the value, it should be 0.9 and above. Then only it is a good power factor. 0.35 is it's not a good power factor. It's a worst power factor. You must know all these things, sir. The furnace, arc welding, and induction heaters, arc welding transformers, induction furnaces have very low power factor. We have to compensate them with capacitors. This is the crux of this particular paragraph. This one is group capacitors, sir. Group capacity, increased load capability, same thing. Reduced material cost relative to individual correction. Without connecting with the individual loads, we are grouping the loads and connecting a capacitor. Material cost is saved, installation cost is saved. But in a motor, we just saw when switching on a motor, the capacitor will come into service. When we switch it off, the capacitor will get cut out. But here it is not so. We have to keep one separate switch for the capacitor. Switching means may be required to control amount of capacity used. Advantage of loading capacitors power factor, power centers of feeders is that they can be grouped together. When several motors are running intermittently, the capacitors are permitted to be online all the time, reducing kVA demand regardless of the load. These are all disadvantages. You just go through the PPT, sir. You will understand. Why I am rushing up is to cover the chapter, sir. We are putting the capacitor at mains. Advantage, low installation cost. Disadvantage, switching will usually be required to control the entire amount of capacitance used. Does not improve the load capabilities of the distribution system. Simple, nothing else. Performance assessment. Yes, sir. This is one important point. You must keep it in mind, sir. The voltage rating of the capacitor should match the supply voltage. If the supply voltage is lower than the kVA produced, yes, that means we are using one capacitor, the rate of which is 230 volt, but the supply voltage is 200 only. What will happen? The capacity of that capacitor will drastically reduce in terms of square, that is V1 square divided by V2 square. So this proportion will be in square. We may use one problem we come across, sir, at the end. But in this slide, you must keep this in mind. The supply voltage exceeds the rated voltage, the life of capacitor is very much affected. Yes. What you are procuring is at a rated voltage and the supply voltage is high. This will reduce the life of the capacitor. And we must look into the dielectric materials, sir. Dielectric material make of the capacitor. It affects the loss per kVA. Also, life of the capacitor. All these things depend upon the dielectric material used. Then we must look into them before buying. Shunt capacitors are generally used for power factor correction. Series capacitors are used for voltage boosting. Operation performance. Portable analyzers are used for measuring the charging current or rated current of a capacitor. Sir, generally capacitors consume 0.2 to 6 watts per kVAr, but this is not a loss considering the advantages of the capacitors. So we are accepting them. 0.2 to 6 watts. All these things just keep in mind, sir. We'll face one more questions. What we have to keep in mind while selecting the capacitors and connecting the capacitors. These are all practical points we have faced, and it has been recorded in the energy management textbook also. Nameplates can be misleading with respect to ratings. It is good to check by charging currents. Capacitor max boxes may be an insulated count with empty plates. There will be no plates, terminal plates, and there will be only terminals and insulated compounds. Capacitor for single phase motor starting and those used for lighting circuits and all what we use for voltage, sir, voltage boosting and all, they cannot be used as a power factor correction capacitor. They do not match. The microfarad may be same, but they do not withstand the power system conditions. They are manufactured differently. These are all the points we must keep in mind. So we have rushed up to finished capacitors. Now we are coming to transformers. Transformers, all of you knowing about transformers. There are two major categories, 33 kV to 400 kV. They are termed as power transformers, and below 33, that is 11 kV and below, are termed as distribution transformers. Rating of capacity is calculated on the basis of connected load and diversity factor. What is the diversity factor? So diversity factor is nothing but for a particular area, if the connected loads, we calculate the connected loads and we find it as 800 kilowatt. But actually, when we use a online meter and check the load even during peak hour, it will not be beyond, was say 450 kilowatt hour or so. Sorry, kilowatt or so, not kilowatt hour, kilowatt or so. What's the reason? Because it is due to the fact of diversity. Because all the loads will not be run at the same time. Because the fridge will be running all the day, but the bore pump will not run all the day. Am I right, sir? So here comes the diversity factor. Rating of the capacity is calculated on the basis of connected load and the diversity factor. Diversity factor we have to multiply it.
You mean less loaded, sir?
Yes, sir. Yes, sir. If the connected loads are 700 kilowatt, and we may have to multiply it with the diversity factor of 0.8 or something, and we'll get something 490, 480 or something. Then we'll be using 500 kV transformers. 500 kV or so. That's why the diversity factor is used. For calculating the capacity of a transformer, connected load multiplied with diversity factor will be used. Transformer should be placed to the load center. Why at the load center, sir? This one important point, sir. Transformer should be placed to the at the end of the load. Why? Because nothing complicated, sir. Simple. If the transformer is placed near our home, the voltage up to our residence will be 11 kV. Line loss will be reduced. Am I right, sir? The LT line will be shorter, ST line will be longer. So line loss will be contained within the limit. That's all, nothing else. Generally, the transformer efficiency varies from 96 to 99%. Losses in a transformer, no load loss. So the no load loss is the humming sound we are hearing in a transformer whenever we energize it even without connecting load. It is called the magnetic no load component, and it is the magnetizing load. During no load also, there will be some losses due to two major factors. One is AT current loss, the other one is hysteresis loss. Hysteresis loss is nothing but the alternating current goes positive and comes to negative. The hysteresis loss, you might have magnetizing and demagnetizing, will make the dipoles align and de-align again and align. So this will make internally some heat. This will produce some heat. The heat will be lost, and this is termed as hysteresis loss. The AT current loss is also a no load loss, because the varying magnetic field will induce not only in the conductor, sir, it will induce voltage in the core also. So there will be some circulating current in the core also. That's why we are laminating it. When we are laminating it, the resistance of the closed path of the AT current will get more resistance to flow of AT current. That's why it is being laminated. Otherwise, we can have it in a solid square shaped shaft. That's why we are laminating it. Load loss is called copper loss. It will be proportional to the load only. You can see that gray area, sir. This gray area is irrespective of the load, it will be constant, that is no load loss, that is iron loss or magnetizing loss. The black curve goes up, it is proportional to the load we are using, sir. Okay, for off load and full load, this will go gradually. Why this is a curved shape, sir? Do you understand why? Why it is not a straight line? Why it is going like a parabola?
When current increases, the loss is also increases.
Yes, sir.
Directly
But-
proportional.
No, sir. I am asking why it is not a straight line, why it is a curve. Where is the square of the current, sir? Square means it will be in a curve only.
Okay.
It will go steeply as the x increases. Nothing but a power formula, sir. We'll solve some problem in the next class. Sir, actually we discussed on about this thing, sir. In this morning with Dr. Mary, I discussed, we have got 10 chapters in paper 2. I thought of completing the 10 chapters in 10 days. And definitely we will not be able to complete one lesson in one day. But instead of completing in day 1 and day 2, the same chapter, we will complete, we will rush up on the first day. And again, we will revisit and complete the balance portion on the 11th day. It will be easier for us to recall everything. Similarly, for the second chapter, we'll rush up on second day and again revisit it on the 12th day and complete the balance portion. That's what we discussed this morning, sir. Is it okay for all of us?
Okay, sir.
Okay, sir. Very well.
Okay, sir. Okay, sir.
Thank you. Thank you. The tab changing and all. What is the tab changing, sir? Tab changing is nothing but this is the cutting off some of the windings so that the voltage ratio will vary.
Primary winding.
Yes, sir. Yes, sir. Nothing but what is that on-load tab changer? On-load tab changers. Supposing between 1 and 2. 1 and 2 means both 1 and 2 are in contact. Suppose we need to connect 3 and 4. So we'll be cutting this winding off. So what should happen? While rotating this to 3 and 4, what will happen, sir? In the intermediate position,
Make and break.
yes, 1 and 2 will break. But the on-load tab changer adopts the principle, first make, then break.
Yeah.
Yes, sir. During that time, it will be connected with a short term. Yes, sir. Yes.
Resistor
So,
will be connected.
the winding connection will be in the.
Will not be
will
disconnected. It will be-
Yes. Always connected. Parallel
When
operation.
transformer in
Yes, sir. On transformer. Parallel operation. These are all the points we need to keep in mind. Supposing they may ask for 3 mass or 5 mass. Phase angle differential, primary and secondary, same phase angle difference, same voltage ratio, same percentage impedance, parallel operations are same polarity, same phase sequence. 5 points you must keep in mind. The energy efficient transformer, what is the difference of grain I just told you eddy current loss is because of the resistance in the laminated sheet. Why we are keeping that laminated sheet with a conductor? Can we make it as a non-conductor? Why not? It should be a magnetic material, sir. Then, am I right? It should be a magnetic material. But the disadvantage is the magnetic materials are conductive. That is the recent amorphous metal transformer is a new metallurgy way of advancement. It has a very low resistance. So we have reduced up to 70% in core loss by adapting to this amorphous metal transformer. Previously, it was grain-oriented silicon alloyed iron. That's all, sir. Simple. Total loss in network. Network loss. We have completed transformer. That's all, sir. Sorry. Total loss in network. Involves measurement of energy loss, energy meters in all locations, starting from the input point to the feeder to the individual consumer. Difference between the input energy and sum of all consumers over a specific duration is accounted as distribution loss in a network of that particular network. That's all. In indirect method, it involves software and all, energy metering. The terminologies we must keep in mind, sir. See one thing, some load flow study where it is energy DTS distribution transformer, sir. One more thing, load flow study is one thing. Application of suitable software. Yes, the third point, conducting load flow studies. This is being done in our tangent code. Load flow study has to be computed. Software has to be used. So we will get a more precise loss measurement. Technical loss and commercial loss. What is the technical loss? Transformation loss. Transformation loss means transformer. Stepping down, stepping up, everything requires some loss of everything. Everything requires some energy. I square R loss, we know. It is a typical, it's not typical, it's can say it as a normative or something. Step up transformer will be losing 0.5%. Transmission to intermediate voltage 1.5. Sub transmission to, yesterday we saw no, in 400 kV it was very less, 98.5 or something, and then it went to 98, 97. So just for understanding, sir. Causes for loss. What is the causes for loss? Are lengthy lines. Lengthy lines means resistance is equal to rho L by A. Rho means resistivity. L is length, cross section A. Inadequate conductor size. Inadequate conductor size leads to low voltage for regulation. DTR located not centrally with respect to load. This is what we discussed a few minutes ago. Low power factor. These are all the points we must keep in mind, sir. Reduction of line losses with improvement in power factor. They have given one particular example. Power factor was originally 0.7, now it is 1. KVA was 428, now it is 300. See the line loss. Originally it was 27.2, now it is 13.4 kilowatts. That's all. Just go through it, sir. High voltage distribution system. This is a new concept, sir. So we will be having one transformer up to our service wire end, that is our nearest pole. There will be one transformer. HT supply will come up to our home and will be getting LT supply directly from 11 kV. So it will considerably.
Transform is fixed at our end, sir.
Yes, sir. Yes, sir. We are in the pole.
Okay.
It will increase the capital cost. That's definitely. Capital cost will be increased.
Yeah. Even if I
Yes, sir.
okay, fine.
Amorphous core transformers, just we saw. This is commercial losses, med trading, discrepancy in med trading, all those things found logged, untraceable consumers, all these things lead to commercial losses. And one more thing, the electromechanical metering, nowadays it is gone almost. Collection efficiency is very good in Tamil Nadu. This theory is for whole India. This book is printed for whole India, not for Tamil Nadu. So we need to read all these points. Yes, sir. We have come to the end. Thank you. But I deliberately kept out of that few more things, sir. We need to complete. I will complete in the 11th day. Sir,
Today is second day.
No, today we can consider it as first day.
First day.
Yes, sir.
Yesterday only
Zero.
introduction.
It is.
From today we have to take into consideration.
Yes, sir.
Oh, we are making February 1st as first day.
Yes.
Very easy to remember.
Yes, sir. Okay. Was it useful or lacking anything?
It's useful, sir. Sir, regarding parallel operation of a transformer. So what about the frequency? Frequency should be same or different?
Frequency will be same, sir. Frequency will be same.
Will be
All over the India, the frequency will be same.
We can also add that point also.
We can add, sir.
Yes.
That is for generators, sir. Transformer will be having same frequency for all terminals. For alternators, frequency shall be same. That is AC generators. That point is relevant to synchronous machines.
Okay.
No, the primary actually rotating transformer is nothing but an alternator. So in such aspect, frequency, the incoming machine and the parallel operating machine, the grid connected machine should be of same frequency is the normal conditions. So frequency is a part of the program. So you need not take it as transformer parallel operation. So transformer is something like it is the SS, it is within the SS. It is not the separate entity. So that's why frequency was not taken. And coming to the ratio, the length of wires. So in entire country, 3:1 ratio was HT to LT ratio. 3:1 ratio was now enhanced after APDRP as 1:1 ratio. And HVDS to LVDS program, you can see transformers like a cylindrical type transformer which is hanging in the pole post itself. That is in Telangana and Andhra, you could see it. So that is the objective. And bundled wire system. That is another thing where conductor losses were reduced through bundled wire system that is available in Porur too. In Porur and Punamalli areas, we could see the bundled wire conductors. So where HVDS and LVDS are taken into account, and it was not there. Now coming to another point, 22 kV, 33 kV power lines, UG cables were laid, but right now 400 kV line is being laid inside the city itself. So that is to reduce the losses. That is one thing. Second thing is that they are laying it for data centers. So normally data centers are rated in a kilowatt only, actually. Normal rating of data centers is rated in power rating only. So it is in the range of megawatts actually. So more than 10 data centers for the entire world is available in Chennai city. So hats off to the entire country as well as the development which is going around us. Power evacuation would be the problem. So, and the source of power was not available, and that's why 400 kV lines been laid. And you could see the menace during the rainy season. It was dug for a very long period near Koratur and other areas. It's lying still date. So it's all this 400 kV. Normally concepts, whatever we have learned is 400 kV would be the outer ring and 230 kV would be the next ring. And then 110 kV, then 66 kV, 33 kV, 11 kV, that is the order. 400 kV would be the interconnectivity. So that is interstate feeders. Right now, it is going to be the intrastate feeders too. So that means to say the source of power may be coming from Bangladesh or Pakistan, and it would be also transferred to the rest of the world. So Asia Pacific region itself been as per 2020 amendment, it has been updated. And when talking about this length and line losses, this is the point which need to be taken into account, where 1:1 ratio has been prevailing for entire country, means it is the best in Tamil Nadu. So as you said, the book is not for Tamil Nadu. We have a very good practice. But one point for discussion is something like this late night, but we need to think about it. Our losses have been categorized as 13%. 13% is the stipulated limit, and we always give you a point that it is 13%. But the theft and T&D losses are categorized up to 54% for the entire country. In such aspect, 13% which is given as a losses for a utility, how come it can hold this much losses, saying that it has lost due to something? And moreover, whatever renewable energy daily they are posting is nothing is available with the utility. The other point, whatever utility doesn't own any renewable energy resources. That mean to say everything is owned by the private people, and the entire in the entire country 50% of our load is from renewable energy. So we have a pride that our LDC is running with 50% renewable energy, but the 50% renewable energy is coming from private players. So the loss is due to such things. So when we calculate T&D losses, commercial losses coming into play, so why the commercial losses are very high? So this is a very big question. So as the practicing engineers, we need to question ourselves why TNEB, the utility which has a very great benchmark starting from many years. So even it has crossed more than 80 to 90 years, because the Engineers Association itself marks its more than 78 years, because 1943 itself it was started. So that's been registered. Still MES has its own legacy. In such aspect, this electricity board is recording 1,85,000. All these things are public money. We need to think about it when we calculate this commercial and technical losses. We are technically strong, commercially we are weak. That's what financial management need to be taken into account. That's what you said, sir. So thank you so much for connecting all such things. Thank you, sir. Thank
Sir,
you.
what is 3:1 ratio? 1:1?
The HT to LT ratio, sir. The HT, whenever HT has been laid, so nowadays you could see a pole which is very big, high. The height of the pole would be which should be carrying HT at the topmost layer, and the bottom that is within 3 feet height, LT would be raised.
Yes.
Yes, that is 3:1 ratio. Now it has been reduced to 1:1 ratio.
1:1 means very close, sir. You mean
HT to LT ratio is 1 to, if it is running for 100 meters HT, we would be having 100 meters LT2. So that means to say HT was in the outer ring, but now it has been brought to the center of the load itself to reduce the losses. So that's what HVDS comes into play, where HT to LT ratio, where the theft can be also reduced. If we have
yes,
one transformer hanging, we would always have a practice. நமக்கு ஒரு கண்ணு போச்சுன்னா ஏத்து வீட்டுக்காரனுக்கு 2 கண்ணு போகணும்னு நல்ல எண்ணத்திலே பார்க்கக்கூடிய எண்ணங்கள்னு வச்சிருந்தாலும் சரிதான். இந்த லோடை வந்து திருடவும் முடியாது. 4வது லோடு போறப்பயே தெஃப்ட்னு போட்டு ஃபியூஸ் கட் ஆயிடும் ஆட்டோமேட்டிக்கா. So this is how it was planned, but nothing was executed. So to be noted down. Okay, anything which is talking in public should be curtailed. Okay, thank you so much. வேற ஏதாவதுன்னா நாளைக்கு கிளாஸஸ் வந்து சாரே தான் எடுக்கிறாங்க, 10 கிளாஸ் எடுக்கிறேன்னு சொல்லியிருக்காங்க. இவங்க
நான் அந்த ஸ்கீம் சொன்னேன் இல்ல, அந்த ஸ்கீம் சொன்னேன். அது வந்து நான் தான் எடுக்கிறேன்னு சொல்லல, யாரும் எடுக்கலாம். அது எடுத்தா அவங்க 10 நாள் கழிச்சு இன்னொரு பேலன்ஸ் நடத்தலாம் அப்படின்ற மாதிரி தான் அது மீனிங்.
இல்லைங்க சார், குமரேசன் சார் பிபிடி ரெடி ஆயிட்டாங்க ஆடிட்டுக்கு. நாளைக்கு ஒருவேளை ஒர்க் இருந்துச்சுன்னா குமரேசன் சார் நீங்க ரெடி தானே நாளைக்கு?
சார் ரெடி சார், நாளைக்கு ரெடி தான் சார்.
ஓகே, அப்போ ஆடிட்டிங் பாத்துடலாம். அப்போ வெரி கிரேட் சார். அப்போ நீங்க கொஞ்சம் ப்ரிப்பரேஷன் பண்றதுக்கு டைம் இருக்கும் சார். லெஷர் டைம் எடுத்துட்டு குமரேசன் நாளைக்கு எடுக்கும்போது அதுக்குள்ள மேரி மேடம் 4ஆம் தேதி வந்துருவாங்க. ஸோ you could have some more time to make it consolidated so that you can brush up as well as you can fasten your lesson plan also. You would have a very great plan. இதுல கூட ஒரு ப்ராப்ளம் இருக்கு. ஒரு பவர் யூனிட் வந்து 0.8ல இருந்து 0.9க்கு எப்படி கொண்டு வர்றது, அப்படி கொண்டு வரும்போது எந்த வேல்யூ வைக்கிறாங்க, யூனிட்டி பவர் ஃபேக்டர் வர வைக்கிறதுக்கு என்னென்ன பண்றாங்கன்னு ஒரு ப்ராப்ளம் இருக்கும் எப்போதுமே. ஸோ அந்த ப்ராப்ளத்தை பத்தியும் கால்குலேட் பண்ணி நம்ம சொன்னோம்னா பண்ணிடலாம் சார்.
ப்ராப்ளம் போடுது கண்டிப்பா, இல்ல ப்ராப்ளம் வரும். அந்த சாப்டர்ல ப்ராப்ளம் வரும் கண்டிப்பா.
அதுதான் சார், அதையும் பண்ணிக்கலாம் கட்டாயமா. தேங்க்யூ சார், தேங்க்யூ, குட் நைட் சார். பர்னாமன் சார் உங்களுக்கு தான் ஹோஸ்ட் இருக்கு, நீங்க க்ளோஸ் பண்ணிடலாம் சார்.
ஓ ரைட் சார்.